Do you want to do the same points? 1 plus I and 3 plus I, or do you want to pick different points?
I can do the same points.
Okay. Now, with addition, we just added the integer part and added the imaginary part.
Yeah.
What do you think is going to happen when I do 1 plus I, 1 plus 2I? I'm trying to write through the tripod here. 1 plus 2I times 3 plus I. Do you think this will be 3 plus 2I?
No, because you also have to do you have to multiply all the parts. So you do the integers, but then you also do 1 times I, and then you do.
Okay.
It's like multiplying polynomials.
Yep.
Interesting. So multiplication, addition just seemed to work in a very obvious way.
Yeah.
But multiplication, if we started applying that obvious way, maybe we could develop a theory where you just multiply the real parts and multiply the component of the imaginary part. What's wrong with saying 2I times I is 2I, just saying it's 2 times 1?
Well, we're
have
multiplying the i's together too.
Which
Yeah.
it's -1.
Okay. So, you want to do it out? Tell me what this is. 1 plus 2I times 3 plus I.
So you have this. You have 3 plus I, and then 6I, and then you get you have 2 times -1, so -2. So you have 1 plus 7I.
1 plus 7I. Okay.
So we have these points 1, 2, 3, 4. So it would be up here.
1
5,
plus
6,
7I.
7.
Okay.
And then that's your point.
All right. So we got. Let's just check the math real quick. We got 1 times 3 is 3. 1 times I is I. 2I times 3 is 6I. 2I times I is -2. 1 plus 7. Okay. Good. So we started with these 2 points we've highlighted here, 1 plus I and 3 plus I, and we ended up here.
Yeah.
What do you notice about the geometry here?
Well, we don't have a parallelogram this time.
Yeah, good point. We don't have a parallelogram.
Because we got it like this.
Yeah, not a parallelogram. Okay.
This looks like kind of a random triangle.
Is there any connection at all between 1 plus 7I and 1 plus 2I and 3 plus I?
Well, this is straight up and down.
What do you mean?
Is that it's on the same? Because we've got a 1 plus here, so this should be
straight up?
No, that's vertical.
Yeah,
Okay,
vertical.
From there. Okay, that's fine. We didn't draw it perfectly, but that's okay.
I don't see much of a connection between these 3 points.
What was something you checked last time?
The distances.
Yeah, why don't you check that?
So, 1 plus 2I was √5. 3 plus I was √10.
And you have
1 plus
7I.
which is √50. Huh. So the distances actually do multiply together.
Okay, in this case, in this one we just sort of picked at random, the distances seem to multiply.
Maybe we could try another one
Sure, let's do it.
and
Try.
just see if the distances continue to multiply.
Okay, great. I have an eraser here. We're sort of cluttered, but
Yeah.
we don't need to draw the picture. So give me 2 random points.
Well, let's do 2 minus 3I.
Uh-huh.
And how about 4 plus
2 minus 3i and 4 plus I. Alright, so when we multiply those together, what do we get?
So we get 8 plus 2i minus 12i. It's going to be minus 3, so plus 3. So 11 minus 10i.
Okay.
So distance for 2 minus 3i is root 13. And 4 plus I is 17. And then 11 minus 10i is
220.
21.
Right, and that's gonna be.
Root 221.
Well, no, it's gonna be. Well, because we have the negative 10i, should this be negative?
Well, it's a distance. And distance is always positive.
Yeah, so we go over 11 and we go down 10i. And what we're doing is we're finding this distance and we're saying this is a triangle whose side length is 11 and this is a triangle whose side length is 10. You're right, it is going below the axis and maybe we could say the distance was minus 10. But we're just trying to find the lengths here.
Alright.
So 221. Alright, so the distances multiply.
Well, so we have
17.
100. Yes, they do multiply.
Alright, because 13 times 17 would be 170
Yep.
plus
Plus
3 times 17.
51 is 221.
So again, the distance multiply. It's interesting, the other bit of the geometry here is not necessarily so easy to see, but maybe we'll get it here. We had 4 plus I, so 4 plus I, so this one was sort of like that, and then we had 2 minus 3i over 2 minus 3i. And what you're going to find is that the angles add, which is really cool. So you have a small angle here and a huge angle to get to here. And then you just add on this extra angle from there and you get to there. So the angles add, which is remarkable. But let's talk about one last thing. Let's talk about the factoring, okay?
Alright.
Alright.